Lord Kelvin spent years analyzing and predicting tides by hand. Then he had a stroke of inspiration. Could you design a machine to carry out these calculations automatically? In Kelvin's words, to substitute brass for brains? Mechanical calculating machines like the abacus had been around for millennia, but they were far too slow to respond to dive bombers. These new calculating machines sped things up by using electrical pulses. The committee considered naming these devices after the pulses they used, but member George Stibitz proposed a more general name, digital, because these machines operated on numbers themselves, or digits. And this is the origin of the term digital computer. But digital would have to wait. Researchers at Bell Labs had recently invented an analog electrical device called an operational amplifier, or op-amp. It could perform mathematical operations with voltages, like addition and multiplication. They used these op-amps to create an analog computer that could solve the ballistics equations for anti-aircraft guns. Using radar and optical sights to obtain the speed, altitude, and direction of enemy planes, the M9 gun director, as the computer was called, could rapidly calculate the correct trajectory and fuse setting. Potentiometers were used to ascertain the direction the gun was pointing. During the war, the US invested big in analog computers. If you break down their total military budget, the third largest single expense was the development and production of an incredibly complex mechanical analog computer called the Norden bomb sight. Unfortunately, they didn't get their money's worth. In the United States, the military invested in an enormously complex and expensive digital machine known as ENIAC. It was designed to speed up the calculation of land artillery firing tables. At the time, these were computed using differential analyzers, the analog mechanical computers based on Kelvin's harmonic analyzer. Although not finished until after the war, ENIAC demonstrated the power of digital computers. It's considered by many to be the first modern computer. What really opened the door to this digital revolution was the discovery made by Claude Shannon in his 1936 master's thesis. He showed that any numerical operation can be carried out using the basic building blocks of Boolean algebra. Two values, true or false, also notated as 1 or 0, and three operations, and, or, and not. This makes digital computers the ideal versatile computing machines. In contrast, each analog computer is an analog for only one type of problem. Furthermore, since digital computers operate on ones and zeros, they are more resilient in the face of noise. It would take a large error to mistake a 1 for a 0 or vice versa, whereas even small errors in analog computers can grow and ultimately swamp the signal. So these days, everything is digital. Our phones, computers, and internet data centers, even TV and radio is now being broadcast as digital. And the advantages are obvious. Since digital devices operate on symbols, usually zeros and ones, they provide exact answers. And repeat the calculation and you get the same result. They are robust to noise. Plus, since only a few components are required to perform virtually any computation, those components have been miniaturized and optimized, making digital computers the ideal universal computing machines. So you would think analog computers would be long gone, a relic of the distant past. But analog may now be making a comeback. There are startups actively working on analog computers. Why is this happening? What could be the benefit of analog? I wanted to put all of this into one video, but the story is too good to bury 20 minutes in, so that is coming up in part 2.